All right, so I'm going to introduce Vicki Johnson now, who's doing a presentation in the August meeting. This one is actually pre-recorded, but for you members on tonight, you'll see it in August anyway. I'll turn it
Okay.
over to you now, Vicki.
Okay, thanks, Wayne. My topic tonight is human colonization of Mars, biological and psychological challenges. Now, obviously, this is a big topic. I've just looked at some of the material and I've just tried to get the main themes for this. So, Mars is a horizon goal for human exploration due to its potential for past life and its value for scientific discovery and technological advancement. Colonizing Mars is one of humanity's most ambitious goals, and the debate surrounding its feasibility is complex. Some argue it serves as a safeguard for human survival and fosters significant technological advancement. Critics, however, highlight the severe environmental risks and the imperative to prioritize Earth's pressing challenges. The vision for a future on Mars began first before the birth of NASA and the European Space Station Agency. It began nearly a century ago, connecting Nazi war machines to a space race with Russia. After World War II, Werner von Braun, along with 100 German scientists and engineers, were brought into the United States through the US military operation project Paperclip to continue their work. Werner von Braun commenced work on plans to reach and settle Mars, and he and his scientists were the architects of the Mariner missions and the NASA Apollo missions. However, there remain many questions regarding the potential for human survival and evolution in the extreme environments of space. The prospect of living on a planet such as Mars raises the possibility of significant changes to our species development. The success of Artemis 2 is shaping NASA's return to the lunar surface and future missions to Mars. The agency is prioritizing a sustained human presence on the moon. So they've refocused their attention on the moon, and they have employed 3 companies which will land science payloads to support a permanent lunar base with the aim of landing people by 2028 and commencing construction by 2030. So what happens to the body in space? It takes approximately 8 months to travel to Mars after leaving Earth's orbit. Mars has about 1/3 the gravity that we have on Earth. The atmosphere is mostly carbon dioxide, but it provides little greenhouse effects, so the swing from daytime to nighttime temperatures are around 100 degrees Celsius. Daytime temperatures usually average around, say, 20 degrees to -20 degrees and around -70 degrees Celsius at night. The air can't be breathed and its surface is bathed in radiation. Air pressure is less than 1% of Earth's, and there is an absence of a protective magnetic field which leaves the planet exposed to intense radiation. Prolonged exposure to weightlessness causes significant physiological changes. Fluid distribution becomes more uniform. On Earth, gravity causes more fluid to accumulate in the legs, requiring the heart to pump blood upwards to the brain. And this is why you often see astronauts with maybe puffy faces. They can have eye problems and ear problems as well. Over longer periods of time, the muscles start to weaken, particularly in the lower body and the back. As our bones respond to muscles, the bones also weaken to losing density. Increased radiation exposure and microgravity lead to muscle atrophy, the disruption of vestibular systems affecting the sensory network in the inner ear that provides the brain and the vital information about motion, head position, and spatial orientation, and decreased bone density and the risk of genetic mutations leading to cancer. How might humans growing up in this environment evolve differently? Well, this is quite a long stretch because humans need to, first of all, survive on Mars first before, reproducing. But as Mars has 1/3 the gravity of Earth, it is approximately 1/3 of the gravitational pull. Although the effects of this environment on humans are not fully understood beyond simulated spaceflight, it is assumed to be comparable to the effects of weightlessness. If a child is born on Mars with the genetics of an Earthling, they will lose bone density throughout their life. It also means a woman born on Mars giving birth to a child is going to experience dangerous forces if her bones are weakened. Over time, this might mean that those with denser bones have a higher chance of surviving childbirth. So NASA's research on the effects of space on the human body. Earth's atmosphere and magnetic field shields us from harmful UV and ionizing radiation. In space, solar radiation increases, damaging human cells and mutating DNA, leading to cancer. It can also affect the central nervous system, causing nausea, vomiting, anorexia, and fatigue. On the ISS, astronauts face 10 times higher radiation than on Earth, but the station's location within Earth's magnetic field make it safer than outer space. The Apollo missions relied on astronauts being outside Earth's protective magnetosphere for only 10 days. However, astronauts traveling to Mars would encounter radiation levels higher than humans have ever experienced and be exposed to them for much longer. In this slide at the NASA Radiation Lab, they have a galactic cosmic ray simulator. It is a particle accelerator where a biological sample is exposed to simulated space radiation. This can tell us how humans might be affected by galactic cosmic rays. NASA researchers at Johnson Space Center also study microorganisms on the International Space Station to understand their evolution and potential impact on long-term space habitation. Microorganisms like bacteria evolve much faster than we do. Understanding them will be essential if we ever establish a long-term presence in space because we bring microbes with us wherever we go. Bacteria that travel to space on our bodies may tell us something about evolution on a much shorter timescale than in space. It might also form new potent pathogens that we must protect ourselves against. So, can we modify our bodies to withstand space travel? One approach to safety undergoing long-term space travel is to modify human bodies and genetics to make space a safer environment. The limiting factor is knowing, what genetic changes, need to be made and how safe these changes are. There are ethical questions and considerations, of course, alongside technological and biological limitations are major unanswered questions about thriving beyond Earth. Questions such as should humans go into space on a one-way mission? Currently, we lack knowledge about the future of generations and the possibility of human reproduction beyond Earth. Also, too, there is, some discussion about how humans would evolve on a planet like Mars and, would they develop or evolve into a new species? The numerous variables and our limited knowledge are based on a narrow sample of humanity. So mostly the studies that we've already been doing are on astronauts who are generally healthy, white and male. We also don't know if a child born on Mars would ever be able to come back to Earth. It may not even be safe for them. So human psychology in space exploration. As NASA requires astronauts to spend ever longer times away from planet Earth, the stuff that makes up a resilient astronaut increasingly requires a mental toughness that is difficult to train for. Psychological readiness is a factor used to measure an astronaut's ability as a productive team member. The effects of long-term space travel on mental health are less well studied than the negative effects on physical health, and it is not fully understood how long-term space travel, such as a trip to Mars, will impact on mental health. By 2030, NASA's Artemis mission plans to have long-term facilities on the moon, a long, lonely 238,000 miles away from the oceans, planets, and the people on Earth. Spending so much time crammed into small spaces with other people can lead to boredom, stress, anxiety, and depression. Research shows that the more confined and isolated humans are, the more likely they are to develop behavioral and psychiatric disorders. The lack of a day and night cycle can also mess with the body's natural rhythm, leading to a lack of sleep. Of course, the day-night cycles on Mars are very similar to Earth, but there's still an 8-month trip to Mars, and also, these issues are more likely to be seen on the ISS and the Moon. So this is not the case on the ISS and the Moon. Along with fatigue from a grueling work schedule, this could all add to a breakdown in relationships among crew, potentially leading to mission failure. So planetary analogues. So the importance of human psychology to a mission can't be underestimated. There are several Earth-based locations such as remote deserts, polar regions, or underwater stations that mimic the geological, environmental, or operational conditions of space, the Moon or Mars. During these analog missions, participants perform tasks like geological sampling, test equipment, and endure the psychological challenges of living in isolated, high-stress environments. So one of those analogues, the Mars 500 mission, was a psychosocial experiment conducted between 2007 and 2011 by Russia, the European Space Agency, and China, located in Moscow, and in preparation for an unspecified future crewed space flight to the planet Mars. The idea was to simulate a mission to Mars in isolation without fresh food, fresh air, or sunlight. Its main focus was on medical and psychological support for the crew, who would necessarily be confined in a relatively small spacecraft with relatively limited medical facilities for the 7 to 9 months journey to Mars. As a six-man crew spent 520 days sealed inside a mock spacecraft in Moscow to simulate the psychological and physiological toll of a full-duration round trip to Mars. The 520-day isolation period between June 2010 and November 2011 was divided into 3 stages: a 250-day virtual flight to Mars, a 30-day surface exploration phase, and a 240-day return journey. There were different crew members for each of these 3 stages. The crew were hermetically sealed, living off limited consumables and experiencing communication delays that realistically stretched up to 20 minutes. During the Mars 500 experiment, related additional experiments aimed at studying the effects of radiation, health problems associated with weightlessness, such as hyperkinetic disorders, and these are conditions that are caused by physical inactivity and sedentary lifestyles. The impact of fire on board the spacecraft, and others were conducted. These included cardiac experiments, immersion experiments to replicate weightlessness, hyperbaric experiments, and radiological experiments. The psychological effects. The 520-day isolation crew overcame difficulties and maintained friendly communication throughout the trial. Cultural differences and language barriers did not significantly impact the project. However, later in the experiment, the crew spent more time in bed or engaged in personal activities. The crew's overall activity level plummeted in the first 3 months and continued to fall for the next year. On their return journey, they spent 700 hours more in bed than on the outward journey. 4 of the members suffered from sleep and psychological issues. 1 crew member slept very badly, suffered chronic sleep deprivation, and accounted for the majority of mistakes made on a computer test used to measure concentration and alertness. By the end of the study, most of the crew members were suffering from insomnia and other sleep disorders. Another analogue is the High Seas mission, and that is located on the slope of Hawaii's Manu Lau volcano and has been a frequent spot to simulate the surface of both the Moon and Mars due to its unique location and geological similarities. Some missions have become important testbeds for future explorers to prepare for space exploration and provide insight into the psychology of people put in isolated, confined environments. The purpose of these missions is to explore the risk of future astronauts' performance deteriorating when teams are unable to cooperate and communicate well. The High Seas program ran in an 8-month Mars simulation mission to figure out which psychological traits might help us put together crews for solo and long-term exploration trips. Some of these include having a diverse cultural or religious background. Others may be how well a person communicates or empathizes with another. A study of 3 6-person crews during simulated Mars missions, 8 to 12 months, analyzed stress responses through biomarkers, wearables, and self-reports. So the wearables are devices that are just located on the body, or they're strapped to the body, and they measure the contact between crew. The findings support a 4-stage model of stress in isolated and confined environments. First one is eustress, of initial adaptation. That's high stress hormone levels at mission start. The second stage is deprivation due to prolonged isolation and confinement, decreasing dopamine and serotonin levels. Stage 3 is disruption of individual and team dynamics, changes in activity levels, mood, perceived stress, and social participation. And stage 4 is asynchronous coping. There's changes in sleep-wake cycles, outlook, and team cohesion. These findings support several aspects of prior theories in combination, such as the elevated alertness at mission start and that adverse conditions are most likely to develop after the halfway point of a mission. For example, for the High Seas 8 to 12 months mission, after approximately 7 months, followed by a period of volatility until the end. So the Antarctic winter team analogues. So specific space analog stations like NASA's Hera in Houston, High Seas in Hawaii, Lunar Airs in Poland provide realistic simulations of missions to the Moon or Mars. However, these simulations are often limited by their shorter duration and the fact that they remain accessible in case of emergencies, thus lacking the full psychological stresses of an actual space mission. However, those previous analogues, they did run some quite long missions. For this reason, researchers have turned to Antarctic overwintering crews to study the effects of prolonged isolation and confinement. Antarctic overwintering crews have become a popular focus for research due to their similarity to the long-duration space missions. Their analog environments share key characteristics with space missions, such as heavy reliance on technology for life support, hostile external conditions, limited rescue options, communication delays, confinement, and multicultural teams working in small, isolated settings. Human behaviour in Antarctic stations is defined by the realities of living in an isolated, confined, and extreme ice environment. Psychological stresses such as constant close contact, confinement, and 24-hour darkness can amplify minor frustrations, sometimes leading to heightened interpersonal tension, loneliness, and in severe cases, conflict. Research into human behaviour in these extreme conditions identifies several distinct psychological and social phenomena. Circadian rhythm disruption, the drastic shifts in daylight, heavy heavily impact sleep quality. Lack of a normal day-night cycle combined with altered hormone levels can trigger mood swings and memory impairment. Social fragmentation and paranoia. Prolonged confinement sometimes leads to crew polarization and mistrust. Studies at remote locations like Concordia Station, which I'll talk about in a minute, shows that frequent close-range interactions don't always equate to social support. And the host-parasite dynamic. Small, isolated groups tend to become self-absorbed. The expedition team becomes the sole source of external social support, and minor irritations with the colleagues' habits are exaggerated. Tasmania-based Australian Antarctic Division leads the Australian Antarctic Program. Their partnership undertakes scientific research in Antarctica, the subantarctic, and the Southern Ocean. Findings from 2 Australian Antarctic Program studies are informing astronaut health and future space missions to the Moon and Mars. Expeditioners and doctors at Australia's Antarctic and subantarctic stations are collecting data from these 2 projects. So the Concordia Station findings. One research team studied a 10-month Antarctic overwintering mission at Concordia Station, which is an analogue for spaceflight, using self-report measures and wearable proximity sensors. 12 crew members were assessed at 4 time points. Results revealed a progressive increase in feelings of loneliness and conflict, while cohesion and individual performance declined. Overall, they observed a progressive deterioration in both individual psychological outcomes and team dynamics. That is, an increase in loneliness and conflict and a decrease in cohesion and performance. Loneliness and paranoid thoughts increased over time, team cohesion declined, interpersonal conflict intensified, and perceptions of individual performance diminished. These patterns are broadly consistent with prior findings from space analog missions and polar expeditions, and underscore the psychological toll of extended confinement and isolation under extreme environmental conditions. When people interacted closely, it seems to lead to more conflicts, paranoid thoughts, and negatively related with individual performance. This suggests that just being in contact more often didn't mean that they were getting the social support that they needed. It also looked like social interactions were getting more focused on national groups, which could lead to social fragmentation and crew polarization. Therefore, monitoring psychosocial functioning during extended missions is crucial, as close confinement, not isolation alone, can cause interpersonal strain. This case study of a single winter over crew provides valuable insights into group functioning in extreme environments. However, the observed patterns should not be generalized due to the small sample size and potential variations in team dynamics across different missions. So the Sinai Antarctic Research Base. Other Antarctic research by Rebecca Kaiser and Hanny Nielsen from Utah's University of Tasmania looked at Antarctic governance and crime in isolated, confined, and extreme environments, such as Antarctic and space stations. Rebecca specifically investigates how station cultures evolve in isolation, where factors significantly influence conflict, and what can be done to improve safety in these environments. Sinai 4 is located on the edge of a steep cliff in Vesles-Carvet in East Antarctica. In March 2025, a scientist at the base accused a colleague of physical assault. The victim alleged that the attacker threatened to kill him, creating an environment of fear, intimidation, and concerns for their safety. They weren't due to leave the extremely isolated and remote base until December. According to Kaiser and her team, there have been multiple cases of misconduct in Antarctica over the years, which has included physical attacks, stabbings, and arson, which eventuated in the station's evacuation. In 2000, the death of an astrophysicist at the Amundsen Scott South Pole Station was a suspected murder. There have been more recent investigations into sexual harassment at multiple Antarctic stations, which highlight ongoing safety concerns. Psychological and social factors. Research suggests several psychological and social factors contribute to conflict in remote locations such as Antarctica. These include prolonged isolation, extreme environmental conditions, and the necessity of constant close contact. In combination, these factors can amplify even minor frustrations. And over time, the lack of external social support, the monotony of daily routines, and the psychological weight of confinement can lead to heightened emotional responses and conflict. Power dynamics also play a crucial role, with limited external oversight, leadership structures, and informal hierarchies taking outsized influence. Those in positions of authority have significant control over how disputes are resolved. This has the potential to exacerbate tensions rather than reducing them. There is a lack of policing and traditional justice systems that are largely absent. So from Antarctica to space, the psychological and social challenges observed in Antarctic stations provide a valuable model for understanding potential conflicts in long-duration space missions. Lessons learned from incidents in Antarctica can inform astronaut selection, training, and onboard conflict resolution strategies. Many astronauts aboard the ISS have reported feeling extremely isolated or overwhelmed during the relatively short trips to space. A 1999 study of 79 space shuttle era missions revealed that 94% of astronauts were prone to using sleeping pills to cope with poor sleep quality and motion sickness. Resilience in space. So Albert Holland, who is a senior operational psychologist at NASA's Johnson Space Center, says that one approach in keeping astronauts physically and mentally well is by making the experience less unusual. He says we're putting normal people in an abnormal environment, but we want to make the environment a little bit more normal. Without structured outlets for stress relief and effective de-escalation mechanisms such as gyms, libraries, gardens, or quiet spaces where mediation between people can happen, tensions can reach breaking point. Some strategies for this include the use of virtual reality. NASA employs VR in various ways, including to facilitate real-time communications with loved ones on Earth. So this is Scott Kelly wearing some goggles. The first augmented reality AR use on a station involved high-tech goggles called Sidekick, which provides hands-free assistance to crew members. These goggles displayed 3D schematics or diagrams of physical objects as they worked, and they also allowed video teleconferences with flight control, payload developers, or other experts for direct support. NASA is also exploring options to use it as both a recreational device and as a tool to boost crew morale. The agency could use it to simulate relaxing environments for astronauts. So astronaut selection, psychological training, and other various kinds of in-flight and reintegration support, in addition to normalizing the experience, has a profound effect on astronauts' mental health. So, what we know clearly about astronaut selection tests is quite intensive, and their training astronauts training for psychological development can take years. Factors that go into deciding whether someone has the mental fortitude deemed necessary to carry out complex space missions includes measures like honesty, emotional stability, and performance under stressful conditions, and group living situations. According to Holland, NASA mainly selects individuals who will not only fulfill a mission's needs, but exhibit characteristics such as good judgment, leadership, teamwork, and resiliency when dealing with the unexpected. And as the realm of space exploration becomes more socially and culturally diverse, space agencies must also prepare to contend with the potential for interpersonal conflict or tension between crew members from different countries and backgrounds. The psychological distinction between a crisis response and long-duration sustainability is no longer theoretical. So crew need to obviously train for critical incidents, but they also need to train for enduring long-duration trips. The Artemis program marks a return to crewed missions beyond low Earth orbit, reintroducing humans to an environment where distance from Earth reshapes both operational and psychological realities. While the early Apollo missions unfolded over days, future lunar and deep space architectures anticipate extended stays, greater crew autonomy, and communication delays that fundamentally alter how problems are resolved. So will we ever live on Mars? So Elon Musk's vision and goal is to establish a self-sustaining city on Mars to ensure the long-term survival of human consciousness. Using the fully reusable SpaceX Starship, he aims to transport millions of people and thousands of tons of cargo to the Red Planet to build a multidisciplinary civilization. So this is Elon Musk's vision. However, in space travel, the most crucial ethical question is why? What's the purpose? What are we achieving? It serves the value of knowing we can achieve our goals with hard work and bring people together. However, these philosophical benefits must be weighed against the concrete costs, such as other projects like Earth science research, robotic missions, or affordable housing being neglected due to funding for the Moon, Mars, and Alpha Centauri. So just finishing with a quote or a paragraph from Gary Westphal, who is a science fiction scholar. He questions the inherent value of space travel. In his extensive analysis of science fiction, he finds the logic and drive of the enterprise flawed. He criticizes the argument that space travel represents humanity's destiny, as explorers are often portrayed as braver and better than those on Earth, pushing civilization forward. Westphal objects to the notion that explorers represent the best and brightest and that progress can only be achieved by venturing into unknown territories. He concludes that progress will come from continued stable life on Earth and that a vast new program of space travel will lead to human stagnation. And that's it. Thank you, Elizabeth. Did you have any questions?
Yeah, sorry, I'm muted. Elizabeth, you got any questions first?
Yes, I was going to say that was a terrific talk, and I'd actually read it and that beforehand, like this afternoon. I do have here like some questions in that, and a couple of sort of more like topics and that. They're in no particular order. A couple of, but the one thing that struck out at me when you were going into the research, like for their like mental toughness and hang on, I've just got to find what percentage. What percentage? You might have to edit this a bit, Wayne. Yeah. It struck me that it's very similar to people in jail. I couldn't help but think, particularly those people in life sentences, or particularly those people in solitary confinement, that we'd be going through the exact same thing, like the boredom, the stress, the depression. Are they looking, is there any combination or looking at people in jail or whatever to get what they're getting at, like how they deal with people that would obviously suffer those same conditions?
Well, from what I know, yes, some of the environmental circumstances are similar, but there's a lot of there's a lot of big differences between, yes, the isolation, the boredom, all of that, but there are a lot of other, other circumstances that make it very different to this. Prisoners are very different to, there's just a different demographic in prison, clearly. And, there's also a lot of other, factors involved in prison that, influence behaviors. But I think, I don't think it would be it's probably not a good way of studying how. I think the analogues are better, in understanding people's behaviors, and I think the Antarctic analogues are probably better in understanding how people are in isolation, simply because, the external environment is hostile. You can't get out of there if there are problems. They really have to deal with issues as they emerge, and they also have limited resources. I guess from what I understand, Antarctic stations, they have different types of crews with different skill sets and training, and so obviously they don't have the types of they don't go through the selection and screening tests, as far as I'm aware, that astronauts go through, and they're not necessarily trained for that environment. So, it's probably why we'd see more of that kind of volatility going on in Antarctic stations, as opposed to the ISS and moon expeditions, because, astronauts are, they go through an extensive selection process and screening process, lots of psychological screening. I would imagine. I used to work with defense screening or where selection processes, and that's quite intensive, can be quite intensive for specialized groups. And so it sounds similar to that in a way, I would imagine, but much more extensive, in that they really screen out, they really look at personality testing, personality traits, as they kind of mentioned there. But the training that they go through, from what I read, can take years, and they're trained in different kinds of environments, like caves, other harsh environments, so that they learn how to live with each other. They learn how to manage situations. They learn how to cooperate and communicate with each other. So these are astronauts, and so so that they're somewhat more prepared than, say, people that are taken to the Antarctic or prison. If
Yeah, yeah. I've got to admit that when you were saying, like, in about the Antarctic and the attacks, like the physical attacks on people, that absolutely surprised me and floored me. I mean, I can understand it, but it did actually surprise and floored me. But my next thing I was thinking of as well in all of this is, and I sort of got to be a bit discreet and what I'm sort of getting at here. I know that there's been a couple of married couples that have gone up either to the ISS and whatever. There's been a few. Would they not look at looking at sending married couples? But of course, in the initial things, you'd have to have both the male and the female that would have the academic, qualifications and that. But would that help to solve like to Mars. If the husband and wife were there, like a familiar person, they could continue on with their relationship and whatever. And I'm just thinking the effect when you're at Mars for a couple of years, and trying to put this discreetly, just your normal human urges, if you're getting what I mean, like for and that. I was just sort of wondering if sending married couples and that would sort of help to ease that.
Well, I haven't read anything with regards to that. I haven't found any literature on that, and I'm not aware about couples being sent up. But going back to some of the areas that I was talking about in terms of where, in isolated, environments where there's a small number of people and they're in, small facilities, is that, if you've got married couples or those sorts of situations, it could, cause even more problems with group separation and people,
Ah,
the paranoia and, the conflict and all that going on. So it might actually exacerbate those situations rather than alleviate it.
okay, right, yeah,
But
yeah,
I'm just kind of guessing, going by what I've read.
yeah, yeah. And I'm sort of thinking, do you want to say your own personal gut feeling of that? Do you think, or do you think it would ever work if ever we had to move from Earth to save Earth to go to Mars, to colonize, because if anything ever happened to Earth? And they're all sort of saying, oh, we might need to move away from Earth to save Earth and whatever, going to Mars.
Look, I'm not an expert on this. It was just a topic that I, was interested in. I thought I'd do some reading on it. But I think what struck me, and I think, what's interesting is the more you look at this topic and the more you read about it, um, the more unrealistic it looks. The psychological and biological, challenges are almost, pretty almost insurmountable. And, a mission to Mars would be, in the initial stages would just be survival, whether they're actually
Yeah,
going to live through it. So, I think maybe there's a lot of people in the field that just think this is a long shot and it's just a bridge too far, that it just may never happen.
yeah, yeah.
I don't know.
Yeah. And as you said too, like if a child was born on Mars, it would be very difficult for them to come back the reverse way, to come back to Earth, as you said, because of yeah, I would assume the
Well, I
genetic.
think that's some of the discussion in some of the papers, is that, if man was able to survive on Mars and started breeding, then, they're looking at, different species, new species developing, and new species of human. And because, they're developing within an environment with those environmental conditions. So, genes, would mutate, DNA would start to change. And so, yeah, could humans go back to Earth after, several generations of living on Mars? I guess that's the question. But
Yeah.
they may not even be able to live on.
Yes. True.
But I think, it just, from what I've read, it just seems like it's in the realm of fantasy.
Yeah.
And, I'm an outsider just looking in.
And what got me as I was sort of listening to your talk and that was when you were saying like the mental toughness and what you're needed to actually survive on Mars to live. There'd only be there wouldn't be that many people on Earth who would be able to get that mental toughness. Do you think there'd be enough of a gene pool that we could start to colonize or send people up? I mean, I that would have that ability and the mental toughness in being able to cope.
Look, I don't know, but I think, they've, the first step, and they've done well with the Artemis 2 crew in the way that they have selected and trained them. And, they've been trained to be, it comes from personal characteristics and traits, but also the way they've been trained, that they've developed that personal toughness. It takes a lot of work, and it's not just something that happens, within a few months. From what I read, they train, for several years for that role. So, but, if you're going to put a civilization or a community on Mars, do you put everyone through that? So,
Yeah, exactly. Well, that was what I was thinking. Like, do you put everybody back here on Earth to do that? Then you pick your, yeah, and whatever. That's what I was just thinking. If there'd be enough of a gene pool, yeah, yeah. And my final question on the old golden old that we all ask: do you think? Well, when do you think that we'll ever colonise Mars? Do you think all of us will see it in our lifetime, or are we looking still a little bit down the track?
Look, I'm not an expert in this area, and I've only just done reading over a couple of days or a week. However, when I read the material on the that I've just presented, it looks, it looks pretty uh, insurmountable.
Yeah,
Trying to get over those sorts of things, let alone all the other, engineering technological issues. So,
yeah,
you know,
yeah,
and when you read that material, it just does look so, unreachable. And and that's why I finished with that last slide with Elon Musk's vision, how far-fetched that actually looks. But
yeah.
that's just what came to my mind when I was reading through it.
Yeah, yeah, yeah. Oh, well, good luck to them. I mean, let's hope we can get there one day. They said all the same things. I'm presuming that, like in the Apollo era, and that, oh no, can't be done. We can't do it. But it's amazing what you can do. So let's just hope and see that they'll, yeah,
Mm.
go on. But that was an excellent talk, and certainly pause for thought that damn, I probably won't even get to see them, one day up there,
Thanks,
which I'd
Olivia.
love to.
Okay,
Yeah,
so I'll say something. Yes, I think Elizabeth, and you made some good points about the whole thing. In terms of Elon Musk, look, some of Elon Musk's original comments, and remember, he's been talking about this for about 20 years. It's not like 5 minutes. Some of it is based on the fact that he does think that they're still going to screw the earth up.
Yeah,
So
yeah,
the idea is having a second civilization in case,
yeah.
and that isn't necessarily a bad idea. So you might, if you're forced into a situation, some of the things that we're talking about might not be effective, but irrelevant, I should say. In
Mm.
other words, yes, there's issues with people. However, it's pretty obvious that in an ideal world with astronaut selection, one thing I noticed with your test results there about what makes the best astronauts. Interesting that the two main factors that they were interested in is personality and physicality, which
Mm,
means that they have to be people that get on very well with others, but also physically fit and strong. Now that's probably true, and it's less. Brains is part of it, but the two main factors that seem to work well best for astronauts are those two things, which does make sense looking at the people. They also happen to be very smart, but
Yeah.
in terms of the long duration missions, if they can't get on with others, it's not going to work.
mm,
So,
Well, that's
um,
exactly right, Wayne. And if you read any of the Artemis 2 training, articles that are around, they talk about how much time is spent with psychologists doing team building, communication skills, conflict resolution. They do a hell of a lot of work on that. And being in confined spaces around the place, in, stressful environments and having to work as a team. So, it's not their first experience when they go up and they're in a small, spacecraft, that they're already replicating that over months and years on Earth. So, but they
yeah,
have to have you're right, they have to have those basic qualities or traits initially to be, before the training, and that's usually comes from, intensive sort of psychological screening.
and also the other comment about married couples. What I recall, that usually NASA doesn't like putting married couples on missions together. That could be because of the interpersonal stuff that they don't like that interfering with the mission. There is married couples in the astronaut corps, but generally speaking, what's happened is they've married after they've started being astronauts. So there's a couple of instances where I think they did the first SpaceX test mission, but both the pilot and the commander, they were actually both married to other astronauts,
Oh,
believe it or
really?
not, which was quite interesting. In fact, one of them might have actually been up in the ISS at the time. But the thing was that That it is does happen that astronauts end up marrying other astronauts. I mean, even in the case of Andy Thomas, remember he married another astronaut.
Mm.
So there is a bit of an age difference between he and his wife. But what I'm saying is it certainly happens. But I don't think that in terms of the policies, whether or not they'd want to select them for these long duration missions, sure, that does make sense, Elizabeth, in terms of some of the problems. But my take on getting to Mars, unfortunately, is I think we need to go back to the moon and sort certain things out in terms of understanding what's safe and getting the technologies improved. But I still think it takes too long to get to Mars. We need to cut the mission time down to a month, not 8 months. The current propulsion that they've got is not good enough. And that's really what's causing the problem with a lot of the psychological things. If you look at what happened with those crews, you could see that they, as the mission went on, their performance degraded. That was the ones that they did on Earth. You know, the ones that you talked about initially. It seemed to me that the longer the mission went on, the worse their performance was. So that's actually a big problem if you've got to go to Mars, because halfway through the mission, you've got to be really on your best when you've got to go explore it. You can't really be slack. And
Yeah.
it seemed to me that what was going on there was that it became harder for them to focus. So,
Yeah.
you know,
So it looks like they need to do more research on these long duration analogs, they like the overwintering and, and some of those analogs that they've got in those other places, they actually are, they do go on for longer periods of time, but they need to study them more and look at how they manage those, those interpersonal issues or the mental health issues, over long duration, which doesn't look like they've done a lot of. I
I
don't know.
think I think I'd make a comment about the Antarctic ones. Yes, it can seem that there's obviously been problems with that. I think part of the problem though is that a lot of the times the selection to go there is partly based on technical skills, and they probably don't do enough interpersonal checks,
Yeah.
and that's the difference between the astronauts. They're probably a bit more careful with checking the personality types of the people they're going, whereas the other ones, well, there is a lot more people going, and they don't go into that level of screening. So that's what's happened with the fact there's been physical stuff going on, with even sounded like a murder potentially, on one of the missions, leaving that. I don't think that was an Australian base, but obviously one of the other ones. But
I think it was
that's
a
not.
Russian one.
The Russian one. Okay, that figures, because maybe the screening wasn't very good. But yes, I think it's. But look, it's something that people need to consider. And I know that Scott, when he's talked about this a couple of years ago, he had some concerns about it, a successful Mars colony as well. And some of them you did mention tonight, in a way, talking about some of the psychological stuff and also the length of time. So as my take on this is that we need to cut the time that we get to Mars. It's too long. And
Mm.
until we can do that, I think if we can shorten it, it's going to remove some of these problems.
Yeah,
Um,
but the Mars and Earth line up where you've got that, that 8 month travel only lines up in that.
no, no, it's not so much the initial orbit. It's just that the brute force required to get to Mars it's too slow. The
Yeah,
current propulsion is not good enough to get there quicker. So if you had a propulsion that was more capable than what they can currently do, it would be less of an issue. So
mm,
the problem is that it's the propulsion's not up there. You still have to use the laws of physics to line it up properly to try and speed it up, Vicky. But the problem is that it's still taking that we don't have enough there's not enough delta V to get us
yeah.
there
But
quicker.
the orbits of Earth and Moon, the Moon and Mars and the Earth are only
It's
aligned
only
every
every 2 years
years.
anyway. Yeah, that's
Yeah.
right.
So
Yeah,
yeah.
that's right.
Is the delay in the communication, like having
Yeah,
the
well,
orbit between.
that's another problem. You really have to make a lot of your own decisions because it's going to be
Yeah,
like maybe
yeah,
10 minutes or something like that to get a response back.
yeah,
You can't rely on the Earth to give you guidance. You've got to have people that have got the right skill set, and this is where it becomes
yeah,
complicated in a crew of six.
Yeah.
mm,
If you've got everybody to cover all the bases.
Yeah.
mm,
I mean, it is as you said, it does look more remote at the moment until we sort some problems out, and that's one problem I'm far more optimistic about setting a lunar base up and trying to work out some of the technologies first, which is why it's correct. The NASA's approach is correct now.
Yeah. So
I
that's
don't.
what I've read too, is that NASA looks like it's just refocusing on the moon and putting its energy in the moon, setting the moon up. There was a rover to go to Mars that they'd had, but they've redirected that to the moon,
Well, it
apparently.
wasn't doing anything actually. That particular rover was sitting around being a test bed, and the thing was, the administrator looked at it and said, "This cost a lot of money to build this thing, and it's very capable. It's also got nuclear power. It doesn't use batteries to run it, which means that if you send it to the moon, you can use it on the South Pole, and you won't have the same issues about looking for sun all the time. And they're trying to find water in craters, and it's actually, if they can get this thing to from a mission perspective, because it's obviously they've got to check out it's quite a heavy rover. That's one problem with it. So they'd have to work out how they can launch it to get there and what instruments they can put on it. But if they can bring this off, it's already been built.
Mm.
It's just that it's obviously not commissioned to get. So that's the big point, is that a lot of the work has already been done with it. So it was sensible in coming up with it. Probably, I think it was the administrator's idea. So, you know, um, anyway, it's an excellent talk, Vicky, and I do think it's. I don't think we'll have to really edit too much on this. So,
No.
um,
Yeah. And the other thing I was going to say too, like in going, like listening to in that, like with all of, particularly these things on the Antarctic, you've really got to have to get them right first, or be a little bit further down the track, because if it's not going to work here on the Antarctic, and if we're having a lot of problems in Antarctica, you've got to solve them first and get them right before you start going up to the moon and Mars and whatever. Because if it doesn't work down here properly, well, it's certainly not going to work
yeah,
up.
it's a psychological thing is the main
And the
main issue.
psychological, and
It's
it's
showing.
an unknown, because how do you know how you're going to react? Like,
Well,
even the most well-balanced person thinks, yeah, I can do 2 years
correct.
Mars, gets up there and has a loony fit.
However, it's more obvious in the case of Elon Musk's proposal. Well, the point is that he was trying to get everybody to go there, which means that the screening process won't be as complete as what's. So that's why there's a lot still needs to be sorted out with this, because the idea that you can just get 100 people on a starship and send them over to Mars, there's going to be issues even at the larger crews, because they can't screen some of them as completely, because potentially they could be tourists that are paying their own way. So there's a
Yeah,
lot of ethical issues that have to be looked at, which you can't really cover tonight. But the amount of information that you've got through your talk is excellent in terms of giving us an idea what the problems are, which I think it's well and truly achieved. So really, really well done.
Right. Thank you. I